have this graph. We're trying to find out which parametric equation matches the graph. So probably easiest way to do that is to try plugging in some easy values for t. Like we'll plug in t equals 0 to start and see if that helps us eliminate some of these graphs. And we'll see what the x values are. If you plug in 0 here, tangent of 0, that means 0 for an angle, so it means cosine is 1. So that's 0. 4 times 0 is 0. So we get an x-coordinate of 0. Then you can check that with your calculator too if you're not sure. Look, we plugged in 0 in for t. 2 times 0 is 0. So if we do tangent of 0, that's 0. Then times 4, that's 0. So we plugged in t equals 0. We got an x-coordinate of 0. If we plug t equals 0 in here, sine of 0 is 0. I had to think about that for a while. It's too early in the morning, I guess. Negative 2 times 0 is 0. 0 minus 3 is negative 3. And again, if it's early in the morning for you too, you could check with your calculator real quick. But if you just do sine of 0, it spits out 0. So that this is 0. 0 minus 3 is negative 3. So that means we expect 0, negative 3 to be a point on this graph if this is correct. 0 on the x, negative 3 on the y, that's not a dot on the graph, so we've already eliminated one of these. If you plug in t equals 0 in here, sine of 0 is 0, 0 times negative 2 is 0, and 0 minus that negative 3 gives you negative 3 for an x-coordinate. If you plug in t equals 0 here, you get cosine of 0 is 1, 1 times 4 is 4, negative 3, 4, that is a point on our graph, so we can't eliminate this one. If you plug in t equals 0 down here, for the x-coordinate, you get negative 2 times 0 is 0, 0 minus 3 is negative 3, and we get 4 again for a y-coordinate. If you plug in t equals 0 here, cosine of 0 is 1, 1 times negative 2 is negative 2, negative 2 minus 3 is negative 5 for an x-coordinate. Then plug in 0 here, sine of 2 times 0 is 0, 0 times 4 is 0. Like negative 5, 0 is not a point on our graph, so we can eliminate this one. This is going to be 0 for the x-coordinate and negative 3 for the y-coordinate. That's not a point on our graph either. So here, plugged in t equals 0, we eliminated 3 of the graphs. Let's try something else that's easy with radian measurement. We can plug in pi over 2, 90 degrees to test these out. And if you do that, sine of pi over 2 is 1, so this is going to be negative 5 on the x. Pi over 2 times 2 is pi. Cosine of pi is negative 1. Negative 1 times 4 is negative 4. And that's possible. Negative 5 in the x, that does look like that crosses at negative 4 in the y, so we can't eliminate this one. If we plug in pi over 2 here, tangent pi over 2, that's going to be undefined actually. Right, because tangent is sine over cosine. Sine of pi over 2 is 1, cosine pi over 2 is 0. So we can't use this to test out this one. So let's try p equals pi. You can plug it into both of them to check, but we just tested this one out. It's got 2 points that have worked so far, so I want to get a second point for this one. You can pick whatever values you want for t. So if I plug in pi in here, tangent of pi is 0. 0 times 2 is 0. That's negative 3 again on the x. And then cosine of 2 pi is 1. Oh, we're getting the same thing. I gotta get a little more creative. How about pi over 4? Because this would be a 45-degree angle. That's one of our special triangles. Tangent of pi over 4 is 1. And negative 2 times 1 is negative 2. Negative 2 minus 3 is negative 5. And then if I plug in pi over 4 over here, that's cosine pi over 2, so that's 0. Cosine pi over 2 is 0. 0 times 4 is 0. So negative 5, 0 should be a dot on the graph. If this one's true, we just found out it's not. So there, by process of elimination, we kept testing points. There's only one left.